3, 2, 1.
Hello, in this video of practical tips in rocket engineering, we're going to be taking a closer look around the blast test chamber. So in this closed blast chamber, we have to think very carefully about the exhaust plume and the extraction system. Above me, we have two vent holes, which allows air to be drawn into the test cell. We have the test stand where the engine will be test firing behind us. And at the back of the chamber, we have an extractor which will take about 1.5 meters volume of air every second out of the chamber. So as the extractor is operating and drawing the air through the system, it will take the exhaust coming from the rocket, mixing that with the air which is being drawn in through our vent lines, and then taking that out of the system and away. There is another way of doing the extraction as well, and that is where we force air into the system. So you could put your extractor, okay, or you could put a pump on the vent pushing air into the system, and then that will effectively push air through and then out through the outlet and through the ventilation hood out the test chamber as well. In fact, some might say that that is more optimal design, because you then don't have the temperature limits on the plume, which if you have the extraction system or the extractor fan drawing the hot air out, you then would have to have a high temperature extractor fan to do that. So there are different methods of ways of extracting the hot plume out of a closed system like this. When we have an extractor which extracts the air out, connected to the outlet, that would lead to a negative pressure within, effectively sucking the air out of the system. And if you were to have a pump or a fan on the inlet and pumping air in, that would lead to a positive pressure within and forcing the air through the system. So two different ways of achieving the same goal. So in our system, we have a number of emergency stops around the test cell. And in most cases, when you press an emergency stop, it would close and cut off all the power to all of the systems. In our case, we shut off all the power to most of the systems except the extractor. It's very important that you do not have a build-up of hazardous gases, so for instance oxygen. And if you are still bleeding oxygen into the system and not extracting it out or forcing it to flow through the system and out the system, then you could have a dangerous situation where you would then have a build-up of oxygen, and if you were to introduce a ignition source, then the whole test cell would have a deflagration event, and there would be a big boom. So in our system, and if you were to operate a closed system yourself, you might want to think about taking the same precautions. Now, one of the risks of running a system like we do by keeping the extractor fan on is that if there is a fire within the test cell and somebody turns on the emergency system, then the extractor will still be on and it will effectively be feeding the flames of that fire. That is a risk that we have taken with our test cell, and is one that we minimize the risk via the procedures that we do during the test firing. And by the way, here's one of the CCTV cameras looking down on our test stand here, and at the back of the chamber, another CCTV camera looking down at the front of our hybrid propulsion engines here. And other sensors we have in the blast chamber are temperature sensors to make sure that we don't breach any temperature limits in our safety system. And around the chamber we have a number of pressure transducers to make sure that we do not breach our pressure limits on our blast chamber. Another consideration that we've done is to mitigate our trip hazards we have ensured that all the cabling that we have going through our test chamber is neatly packed away in their own electrical conduit. So one of the other features that we have in the test chamber is a drip tray at the bottom. So if we do have any spillages, any propellant spillages, or if we are using a water mist cooling system, then all of that water will gather in the drip tray, which we can then pump out. Please be aware of some of the hazards and risks dealing with fine mists and water droplets, okay, and if they are left in pools to stagnate over long periods of time. So the blast chamber has actually 3 layers to it. We've got an outer shell, which is 6 millimeters of steel, which provides the blast and fragmentation protection. We then have the fire and noise retardant layer, which basically cuts down on the noise within the rocket test cell when a rocket is firing. And then we have an outer skin just to tidy all of those components away and gives you the inner layer that we have here. And here is where it all happens. So here we can see a fairly simple hybrid propellant rocket engine. This is one which we would use in our lab for teaching purposes. So when the engine test fires, there will be a flame extruding out of the hybrid propellant engine, and you'll notice that we've got this configuration of metal plates to effectively deflect the plume, okay, up into the extraction system above.